Hello everyone. So today we will be working on WebWork 7, question 14, which is related to linear second order differential equations. So this is your standard initial value problem, which is set up as y double prime minus 14y prime plus 49y is equal to 0. And our initial values are y of 0 is equal to 2 and y prime of 0 is equal to 0. So our first step in this scenario is, as it states over here, we have to assume a solution that y is equal to e to the mx, y prime is equal to me to the mx, and y double prime is equal to m squared e to the mx. So we'll do just that, and we'll take these and plug it into the equation. So y double prime becomes m squared e to the mx minus 14 m e to the mx plus 49 e to the mx equal to 0. And in this case, what we're going to do is we're going to factor out the e to the mx in each of these. That way we get m squared minus 14m plus 49, all as one polynomial equal to 0. And in this case, to get just rid of e to the mx, that way we can just find the roots of this. We just divide everything by e to the mx. That way we get m squared minus 14m plus 49. So this one, if you take a first glance at it, it's not all that difficult to find out, but in this case we are going to have a repeated root. But if you want me to do the work, I will do it anyway gladly. So of course, just assuming the quadratic formula, minus b plus or minus radical b squared minus 4ac all over 2a. Setting it up on this side. So we'll have 14 plus or minus radical b squared, 14 squared in this case, 186. We'll subtract that by 4 times a, which in this case is just 1, and then 49. So 4 times 49 will give us that 196. So this will eventually wind up canceling out, and then all of this over 2. So this cancels out, or essentially becomes 0. We get 14 over 2, which means our repeated root is going to be 7, which will be equal to 1 and 2. So I'm going to keep that over here just to make some space. So now that we have our roots over here, we can write down the general solution of the equation, which in this case is going to be y is equal to, and we use the form of the general solution, which in this case is going to be c1 e to m1, or in this case 7, and the question asks to use x instead of t. And then from here we add c2, but since it is a repeated root, we do have to add an x here, and then again an e to the 7x. So this is just around the time where we would plug in for the initial values. So since we already have y set up, we can immediately do y0 is equal to 2. So just rewriting this here, 2 is equal to c1 e to the 7 0 plus c2 0 e to the 7 0. We already know that anything times 0 essentially becomes 0, but e to the 7 0 in this case would just turn this into a 1, meaning that c1 is equal to 2. Now, to solve for C2, it's a slight bit more tedious. So in this case, what we have to do is we have to find the derivative of this formula right here. And then afterwards, we will plug in that y prime 0 is equal to 0. So, again, just to keep it a little bit clean, I'll write this again in a second. So, just going to write it over here next to our other conditions. C1 is equal to 2. Because we'll wind up plugging that into the general solution again later. So we have y is equal to c1 e to the 7x. We already know c1 is 2, but again, we'll leave that for later. And we have plus c2 x e to the 7x. So in this case, we're going to set up just regular derivatives. So our y is immediately going to become y prime c1 e to the 7x. So c1 is still a constant. So it would just be the derivative of e to the 7x, which in this case would just be 7e to the 7x. In that case, it'll be 7 times c1 e to the 7x. But our second part is a bit different because we do have that x in there. So in this case, we would just use, I'm blanking on the name of the rule right now. That's probably not a good sign. Basically, the power rule. That's what it is. So the way I was taught was you would set up your u. So u is equal to c2x in this case. And then your du, or your u prime, rather, would equal just c2 because it's just the constant left over from u. And then your v, which is going to be your e to the 7x, v e to the 7x, but your v prime will wind up being, again, just 7e to the 7x. So if we plug that in right over here, it would be u prime v plus v prime u. So I'm just going to write it over here again because in terms of space. So our u prime, c2, times v, which is e to the 7x, plus v prime, 7e to 7x, times u, which is just c2x. So I know it's a bit lopsided right now, but again, we can go ahead and just plug in the initial value for this. So we would get 0, which is our y prime initial value, is equal to 7 c1 e to the 7, and again, x is already being substituted for 0 in this case, plus c2e to the 7, 0, e to the 7, 0. And then again, just adding onto this, make some more space again. Then we get 7e to the 7, 0 times c2, 0. So again, this works out nicely because all we have to do, since there's already a 0 here, just cross this out, because essentially this winds up becoming 0. And then our e to the 7 zeros on both the 7c1 and the c2 wind up becoming 1. And we are left with 7c1 plus c2 is equal to 0. And if we just bring one over to the other side, we can get minus c2 is equal to 7c1. And we can immediately solve for c2 because, as before, c1 is equal to 2, meaning that c2 is equal to negative 14. And if we take this and plug it back into our original equation, which is right up here, we get y is equal to 2 c1 e, 2 e to the 7x. And because it's a minus 14 14x e to the 7x. And if you want to factor this a bit more, we can obviously do y is equal to 2 minus 14x e to the 7x.